Hi, everyone. Welcome to the last session of GopherCon. I want to start this off by saying a big thank you to our organizers, our MCs, captioners, photographers, videographers, AV crew, hotel staff, and everybody working backstage and everyone else who made this conference possible. So can you all join me in giving them a round of applause? And thank you all for being here with me for this talk today. If I haven't met you yet, hi, my name is Julie. For the last 5 years, I've been working on the Go team at Google, and most recently, I was the tech lead for the Go security team. About a month ago, I became the tech lead for the Google Cloud SDK team, which develops the client libraries and command line tools that you use to build applications on Google Cloud. I've been part of the Go community for a little while now. I've been writing Go programs for even longer. My first GopherCon was in 2018 in Denver, which was a few months after I had joined the Go team and Google. And this is a photo of me and my sub-team at that time, a few of whom are in the audience today. Since 2018, I've had the chance to meet so many people in the Go community, and it has been absolutely amazing to be back at GopherCon this year, reuniting with some old friends and making new ones. Back in 2018, dependency management for Go was still in its early stages. The introduction to Go modules led me to build the Go package discovery site, learn a lot about dependency management, and eventually work on tools to help developers find and fix vulnerabilities in their Go projects, and that's what I'm here to talk to you all about today. So when I mention vulnerabilities, the first thing you might be wondering is, what does it even mean to be vulnerable? Well, if we look up the definition of vulnerability, here's what Google search will tell us. It's the quality or state of being exposed to the possibility of being attacked or harmed, either physically or emotionally. And there's even this little box here that tells us how important vulnerability is. Vulnerability, it says, can give us a sense of belonging, and it's essential to the human experience. And of course, this definition is referring to our interpersonal relationships. And I'm no Brené Brown, so you can watch her TED Talk later. But the idea and definition for vulnerability for software is actually not that far off. So this is the formal definition of a vulnerability according to the CVE program, which is an organization that identifies and catalogs publicly disclosed cybersecurity vulnerabilities. This definition is a little bit long, but there are a few key components here that we can take away, which is that a vulnerability is something that causes a weakness in your software. And it's a weakness that can be exploited, and this exploitation results in a negative impact, which results in a loss of confidentiality, integrity, and availability. And that is really the crux between a vulnerability in your software versus just a regular old bug. It's that this flaw makes it possible for you to be exploited in this way. So now that we've defined what a vulnerability is, your next question might be, why do we care? Or maybe it's intuitive that we probably don't want our software to be exploited. So your question might instead be, why do we seem to care so much right now? Well, since I was last here in San Diego for GopherCon 2019, one of the things that you might have heard a lot more about is this idea of software supply chain attacks and this need to secure our software supply chain. And that's because there have been a lot of high-profile attacks in the news. Some or all of these you might recognize. There's also a lot of research and statistics being published to back up the fact that there is this rise in supply chain attacks, and it's really happening. For example, according to one source, there has been a 742% average growth in software supply chain attacks over the last 3 years. And lastly, a lot of us care about this right now because, well, at least in the United States, the president told us to. In 2021, there was an executive order that was issued to improve the nation's cybersecurity. And it specifically called out this need to enhance the software supply chain as being vital to the federal government's ability to perform its critical functions. This might lead you to ask, what is the supply chain? What is the software supply chain? Some of you might already be familiar with this concept, but to illustrate its importance for this talk, I'm going to discuss what a supply chain looks like in general. And let's start by talking about the different stages of a supply chain for baking a cake. So let's say we want to bake a cake. For anyone who's baked before, we all know that to bake a cake, we need a lot of different things. You need your ingredients, of course. You got your flour, milk, eggs, and all of those ingredients. But you also need equipment, like a bowl to put the stuff into, and an oven, and baking pans, and a cake tray to serve it on. And when we take all of these ingredients together and combine them in a series of steps, we can produce a cake that's hopefully good and people will enjoy eating it. And we can think of all of these components as our cake supply chain. This supply chain includes everything that you, as the supplier of the cake, needs to do to deliver the finished product to the end consumer, from gathering your ingredients to baking in the oven to serving that first slice of cake. Of course, we can go out even farther of our supply chain, but for the purposes of this analogy, let's stick to what's on this diagram. Now, let's say I have an allergy. For example, maybe I'm allergic to gluten, so I want to bake a gluten-free cake. Well, to ensure that my cake is gluten-free, I need to take steps to prevent gluten from coming into contact with my cake at every step of the supply chain. This means using gluten-free ingredients, making sure all of the equipment I'm using is clean, and taking precautions at every step. And this might seem really intuitive. We, as the supplier of the cake, want to make sure that there's nothing in it that can harm the end consumer, especially if they have a very severe gluten intolerance like celiac disease. And to do that, we need to make sure that at every step of our supply chain, we protect the cake from the substance that the consumer is vulnerable to. We can apply these same concepts to our code and the software that we ship to an end user. So in the same way, when you're building a piece of software, your software supply chain isn't just the code that you write. It is your source code, but it's also the tools that you use for your build process, the dependencies that you pull in, your deployment pipeline, the artifact that you build, and so on until your software has been delivered and executed by the end user. We know when we're baking a cake to check for and not include things that our end consumer is vulnerable to. But what about when it comes to our software? How can we all be so sure that the software we're shipping to our end users is not vulnerable to attack? And as an end consumer, how do we know that this code that we're downloading from a complete stranger off the internet is actually safe to run on our machines? Well, the short answer is that in the same way as baking a gluten-free cake, we need to make sure that our software supply chain is protected at every step of the way. And today we're going to talk about a specific part of our supply chain, which is finding vulnerabilities in our dependencies. After all, we all use open source software. We all download code from complete strangers off the internet, and there's a lot of benefit to doing so. But we probably also want some way of knowing that we're not accidentally putting ourselves at risk and becoming the next one of these headlines. How do we do this? Conceptually, a really straightforward way to do this is just to look at all the dependencies in your project and compare it against some database of vulnerabilities. If you've been developing in Go for a little while, you're probably already familiar with Go modules and the go.mod file. If not, a module is simply a collection of Go packages stored in a file tree with the go.mod file at its root. The go.mod file looks like this when we zoom in on it. So for a given module, it tells you the module path, the Go version, direct dependencies, and transitive dependencies. Conceptually, we can take this file and parse it for all the dependencies, check them against some vulnerability database, and figure out which ones are vulnerable. And you don't need to build this yourself. There are actually a lot of free tools out there that will do this for you. A common one that many of you in the audience might already be familiar with is Dependabot, which will scan your GitHub code base for vulnerabilities. There are a lot of other free scanners too on the market that will scan your go.mod file, but I'm just using Dependabot because I assume that a lot of people in the audience use GitHub for hosting source code and might already be familiar with this product. So every once in a while, I will get an email in my inbox like this, and it'll let me know that there are some security vulnerabilities that have been found in one of my projects. And at the bottom of this email, there's this button that says, Review all vulnerable dependencies. And when I click on the button, it takes me to a page like this, which is really helpful because now I don't have to go and do all of that work myself. GitHub has done a lot of great work to help us reason about the developer experience and about our dependencies. And like I mentioned, many other scanners will also do the same thing, and Dependabot is just one example. There are a few things, though, that we as the Go security team wanted to build upon, specifically to make this workflow better for Go developers. Let's go back to my go.mod file. So you see here that I have 3 direct dependencies in this project. So these are probably the 3 libraries that I actually work with on a daily basis and I'm familiar with. But this page tells me that there are 15 vulnerabilities that affect me. And I'm not really familiar with some of the modules that are listed here. For example, I haven't seen this XML package before, and this page tells me that it's a critical vulnerability, which sounds pretty scary. There's also this XNet HTML one beneath it, and again, I don't really know how this package got pulled into my code. And now, I have 15 vulnerabilities that I have to go and investigate and resolve. I'm not sure if all of these vulnerabilities are even that relevant to me. Some of them maybe I can even ignore, and others I might have to take action. Of course, I can always just blindly upgrade all my dependencies, but that might not be enough. It's very possible that in the fixed version, there is a breaking change or something else that's going to cause problems in my code, which I have to then go and fix. Dealing with and investigating 15 vulnerabilities can be a lot of work, especially if I'm finding out about them just as I'm about to make a release. It can be pretty frustrating to suddenly have all of this extra work and when I'm already under pressure to get my release out. So on the Go team, we've been asking ourselves, how can we use and build on the work that other people have done with vulnerability management? And how can we make this process better for Go developers? So in working on this project, we had 3 main goals. The first is that we wanted to provide a comprehensive and high-quality data source so that when you're reading a vulnerability report, you can be sure that the information is accurate and you have all the context that you need to make a decision. The second is that we want the alerts to be low noise. We don't want to tell you to just go and fix a vulnerability if it doesn't matter to you. And lastly, we want the information to be widely available. We want to bring vulnerability data to the tools and the workflows that Go developers are already using. So our first goal, we want to create a database with comprehensive and high-quality data. And to do so, we pull vulnerability data from a bunch of different sources. This includes third-party sources like GitHub security advisories and CVEs from the National Vulnerability Database. It also includes vulnerabilities in the Go project that we have disclosed and released security fixes for. And lastly, it includes direct contributions from Go package maintainers. So if you are a Go package maintainer and you want to help contribute vulnerability data about your projects, feel free to use this page to report publicly disclosed vulnerabilities that you want to see added to the Go vulnerability database. We then take data from all these data sources, and we take the vulnerabilities and aggregate them into the Go vulnerability database. I mentioned that in order to be comprehensive, we also want the data to be high quality. So each report in this database is reviewed and curated by someone on the Go security team. That way, we can be sure to maintain a consistent quality and style, and we also check for accuracy and will add more granular information, such as data about vulnerable functions that are actually being called. We take all these reports, and they are published using the OSV format, and the database is publicly accessible at vuln.go.dev. Our second goal is to make sure that we're producing low noise alerts so that you are spending your time addressing vulnerabilities that actually affect you. I mentioned earlier that a simple way to find vulnerabilities in your dependencies would be to just take all the dependencies in your go.mod file and compare them against some database of vulnerabilities. Doing this is one strategy, but it can lead to a lot of false positives. Just because something is in your module graph doesn't mean that it's necessarily in your execution path. Going back to my go.mod file, you might think, I only have 3 direct dependencies, and the list of all my transit dependencies fits on one page. And your mental model might be, this is probably what my module graph looks like, so who cares if I have a few vulnerabilities here and there? How much work could it really be to resolve one of them? But this go.mod file is for a project that I spent a weekend working on. For a bigger project like Kubernetes, this is going to be your go.mod file, and your module graph is going to look a lot more like this. And in that case, investigating vulnerabilities in potentially all of these dependencies could take you days or even weeks of work. Well, thankfully in Go, we can use static analysis to save you some time. And as I alluded to earlier, just because a module is in your go.mod file doesn't mean that you necessarily import a package from that module or that you're executing a vulnerable function. So what do we mean by this? Let's say we have 3 modules, A, B, and C. And module A at version 1.0 requires module B at version 1.0, which requires module C at version 1.0. And the reason is because you have package A inside module A, which imports package B inside module B, which imports package C inside module C. And this is because function A inside package A calls function B inside package B, which calls function C inside package C. Now, what happens when function C has a vulnerability? We would then say that package C has a vulnerability, so does module C, which makes function B, package B, and module B all vulnerable, all the way up to function A, package A, and module A. But what if function A was instead calling a different function inside module B? What if function A actually called function D, and function D doesn't have a vulnerability? In that case, even though module C and B still contain a vulnerability, it doesn't actually affect module A at all. And if you are working on Module A, you probably don't want to be alerted of all the vulnerabilities inside Module B and C since they don't actually matter to you. Looking only at your go.mod file can lead to these types of false positives, but we can use static analysis to detect for vulnerable functions in your code and produce low-noise vulnerability alerts. And even though anyone can just read data from the vulnerability database themselves and figure this out themselves, we wanted to make it really easy for developers to scan for vulnerabilities in their Go projects. And we do this by making Go support for vulnerability management widely available through a lot of existing tools that we know Go developers are already using as part of their workflows. And here are a couple places you can find vulnerability information in your workflow. Let's start with the CLI tool govulncheck, which applies the concept we just discussed to surface vulnerable functions in your code. Govulncheck is a command line tool, and you can use it to scan your code and find vulnerabilities in your dependencies. It uses static analysis to try and capture which vulnerable functions are actually being called, and we believe that by having a tool do this, we can narrow down the alerts that you actually need to spend time dealing with so that you can get back to the things that you need to be doing faster. So remember earlier when we looked at our module level analysis and it found 15 vulnerabilities in our code. Here's what happens when we run govulncheck. It tells us that our code is actually only affected by 2 different vulnerabilities. And this suddenly makes this problem seem a lot more tractable. 2 is a lot closer to 0 than 15, and it could mean the difference between having to work late on a Friday night to make sure we don't slip a release. For each of these 2 vulnerabilities, the output tells us the following: a short description of the vulnerability, a link to package site with more information, the module path and version where the vulnerability is found and fixed, and a stack trace. And the trace will actually point you to the exact function in the line of code in your project where the vulnerability occurs. So that way, when a vulnerability transitively affects your code, you don't have to sort through all your dependencies yourself to get a better understanding of how it affects you. The bottom half of the govulncheck output will highlight that this information is purely informational. In that case, it tells us that there are 5 vulnerabilities in packages that we import. And it also lets you know that you probably don't need to take any action. We only include this information in the output because we've heard from our users that developers want this information and they like to know about which vulnerable packages they might be importing. So going back to this list of 15 vulnerabilities from earlier, we now know that only 2 of them actually affect us. We also have a stack trace pointing us to exactly which line of code is being executed, and we have information to deal with that accordingly. We recently released V1 of the govulncheck API, so we hope that it will be useful for finding vulnerabilities in your Go projects. We're so excited to hear about your experience with using govulncheck and integrating vulnerability scanning into your existing workflows. We expect that users probably will want to run govulncheck not only in their terminal, but also as part of their CI/CD pipelines. So as a starting point, we published a GitHub action for govulncheck on the GitHub Marketplace. We know that we hope that developers who use GitHub Actions will find it easier with this feature to integrate govulncheck into their CI systems. Another place we surface vulnerability data is the Go package discovery site, pkg.go.dev. So let's say you're on pkg.go.dev and searching for a project that you might want to pull into your code base. If that package has a vulnerability, you'll see this red badge next to the name on the search page. Instead, if you went straight to the package documentation, you'll see this red banner at the top of the page that alerts you of the vulnerability and gives you a short description of what it is. If you're using a different version of the module, you can click on the versions page to see what other versions might be affected. And the Go package discovery site also gives detailed descriptions of each vulnerability from the database to make it easier to browse and read about the ones that affect you. So these are the pages that are actually linked from the govulncheck output that I showed earlier. And lastly, you can run vulnerability scanning directly from your editor with the Go extension for Visual Studio Code. To scan for vulnerabilities in your module, simply run the toggle vulncheck command. VS Code Go will then query the Go vulnerability database and match information with the dependencies in your project. From your go.mod file, you can see diagnostics for potential vulnerable dependencies. You can also take a code action to run govulncheck and see which functions are actually being called. By hovering over a given dependency, you can look at information about vulnerabilities that might affect you. And from your terminal, you can run govulncheck in the places to see all the places in your code where functions are actually being executed. And lastly, you can upgrade a version of your dependency to where the vulnerability is fixed just by clicking on the Quick Fix option. So that's where we're currently at with Go support for vulnerability management. We hope you'll try it out, and we hope that you'll give us feedback. You can install and run govulncheck from your terminal using the command on the screen. Eventually, we want to make vulnerability detection a part of the main Go toolchain, and we would love to hear from all of you on how the current functionality is working so that we can be building what's best for the Go community. And you can also learn more about vulnerability management for Go and what the Go security team is up to by visiting go.dev/security, where you'll find documentation, tutorials, and other resources to help you write secure and reliable Go code. Thank you all so much for joining me for this talk, for an incredible week in San Diego, and for creating a community that I am so proud to be a part of. So according to the internet, there is no known name for a group of gophers because they live solitary lives in their own tunnels. But as this week certainly shows, that's clearly not true. So on the Go team, we were talking about this, and we recently decided to call a group of gophers a concurrency. So whether this has been your first GopherCon or your 10th, I hope that you had a wonderful week, you made some new friends, and have felt as welcomed into this community as I have since my very first GopherCon 5 years ago. If I haven't met you yet, please feel free to come and say hello, and I look forward to seeing you all again in person, online, and in any place in the world where a concurrency of gophers may gather. So see you all soon. Thank you.